Hello and welcome to another section in further mathematics. In this section we'll be looking at the topic functions and the domain of a function. But before we proceed, I would like us to do a quick review of our previous lesson. Welcome back. Thank you. Now, in our previous lesson we did something about the domain and the codomain of a function Now with this we also did some calculations. Today I would like us to proceed with some other calculations that can also help us to enhance our level of understanding when it comes to functions and mapping. So the question here is, these are example 3. We say determine the domain of a mapping Gx, which implies 2x squared minus 1, 2x squared minus 1, if R is in the range 1, 7, 17, is the range and G is defined on D. Now what we are interested in now is the domain. So the same principle we've been applying before now is definitely the same thing that we'll be doing, but at this point I would like us to just do a direct substitution of the range to this to what we have as a function. So when you substitute the range into the function, then you're done, and that is all about the question. So the first one, let's see, they said the range is 1, 7 and 17. Now let's go to the first one. We have Gx, which happens to be the function we are interested in, is 2x squared minus 1, a direct question. Now what we are supposed to do is let's substitute x as 1, because we have ranges value 1, 7 and 17, which serves as the image to the function. So the first one is 1. You now say when x is 1, you now substitute our Gx to be equal to 1 and is equal to 2x squared minus 1. Now you collect like terms. Minus 1 comes to this other side, it becomes 1 plus 1 equal to 2x squared. So at this point we now have 1 plus 1 is 2 equal to 2x squared. In order for us to have a value of x squared, we divide both sides by 2 and divide here by 2, so that 2 goes with 2. We now have x squared equal to 1. Now the value of our x will now be the square root of 1, which is equal to 1. So at point 1, when the range is 1, the value of our function is also equal to 1. Now let's move further and substitute 7 into our function. Remember, the function is well stated in front of us, which is 2x squared minus 1. 2x squared minus 1. Now let's substitute Gx as 7. We now have 7 implying 2x squared minus 1. Now we take the minus 1 to this other side. We now have 7 plus 1 equals 2x squared. 7 plus 1 is 8 equals to 2x squared. Now divide both sides by 2, so that 2 goes with 2. We now have x squared equal to 8 over 2. X squared is 4. So the value of our else is now the square root of 4, which is equal to 2. So when the range is 7, the value of our x is equal to 2. Now for the last one, 17, here we have Gx implying 2x squared minus 1. So Gx is 17 imply 2x squared minus 1. Now taking the minus 1 to this other side, we have 17 plus 1 implies 2x squared. 17 plus 1 now is 18 applying 2x squared. Now we divide both sides by 2. 2 goes with 2, so our value of x squared is equal to 9. Now in order for us to have our x, we now look for the square root of 9, which is equal to 3. So the domain of the function d is now equal to 1, 2 and 3 respectively. So with this, I know that when it comes to understanding the terms that have to do with functions and its domain, you will not find it difficult to analyze such again. Now let's just list the types of functions, types of mapping. Let's just go into types of mapping. The first mapping I want to list here is one-on-one mapping. One-on-one mapping. Now when you talk about one-on-one mapping, it talks about if different elements in the domain have different images in the co-domain. So for example, if this is our domain and this is our co-domain, remember there are elements here 1, 2, 3, and there are other ones like 4, 5 and 6. If each of these elements is assigned to different elements, it is called one-on-one mapping. That is the one-on-one mapping. Now another type of mapping, this is number 1. Another type of mapping we'll be talking about is called the onto mapping. It's called the onto mapping. Onto mapping. Now in this type of mapping, every element of the codomain is at least an image of element in the domain. So let's say this is our domain and this is our codomain. If in our codomain we have numbers like 2, 4 and 6, now in our domain onto mapping will have 2, 4, 6. So each element in the codomain, this is our codomain, this is the domain. Now each element in our codomain is an image of an element in the domain. So with this we call it an onto mapping. Now when you talk about identity mapping, which happens to be number 3, identity mapping. In identity mapping is where an element is onto itself. So if you have the value of x, y, z, and here you have your x, y, z with the point pointing into, so you have x implying x. So this is an identity mapping. But a situation whereby all the elements in the domain 1, 2, 3, and we have A, B and C, and all the elements in A has an image in just a particular element in B, we call this a constant mapping. Call this constant mapping. So I will say thank you for joining us in this lesson. To refresh your memory on what we've just discussed, please take the test that will appear on your screen.